In this video, we're going to show you how to create a very simple version of stud walls. However, instead of using them for architectural purposes, we'll use these walls to create structural openings, such as doors and windows. Remember that this video is part of a full timber frame residential structural model, and that by the end of the course, you'll be able to create a clean and well-structured model, just like this one. Look at those beautiful trusses and all the studs inside the wall. Elegant, isn't it? Also remember that you can download the DWG files for free to follow along during the process. With that said, I'll leave you with Senior Revit to continue the tutorial. If you have any questions, feel free to leave them in the comments and we'll do our best to answer them. Shall we?
All right, now we're going to start modeling the doors. To do that, first I'll go back to Visibility and Graphics and then select Imported Categories. Here I'm going to expand the DWG file again, and you can see there's an identifier for the doors. A little further down, you'll also find the identifiers for windows labeled as GLAZ, which stands for glazing. Since we're starting with the doors, I'm only going to turn the door identifiers on and then click OK. So now I can clearly see exactly where the doors are located. Before placing them, let's quickly jump into the 3D view and see how the model is looking. As you can see, the masonry walls appear in grey, while the stud walls are, well, not exactly a timber colour yet, but that's fine for now. What I do notice is that these levels are not positioned correctly, so I'll open any elevation view and move them up a little bit. Let me also check the other direction, and yes, that looks much better. Alright, I'll close all these views that I don't need, and while I'm still here, I'm also going to hide the levels. And remember, later in this tutorial, I'll show you how to physically model the timber studs inside the wall using curtain walls, so make sure you stick around for that part. Now, to add doors, the first thing we need to do is download the correct family for structural doors instead of using architectural doors. I'll show you the difference in just a moment. So I'll go to the Insert tab and select Load Autodesk Family. From this window, open the door category and select the first one called Door Opening. Then click Load and wait for it to finish loading. Because there are no door tools in the Structure tab, we need to go to the Architecture tab and select Door from there. In the Properties palette, you can now find the door family we just loaded. There are several types available, but I'm going to open the project browser and delete all the door types except one. Now, the reason why architectural doors don't really work well in structural models is the following. Let me place one door in this wall over here. Not the default one, but the architectural door opening that we just loaded. So I'll click on the wall, and that's it. However, as you can see, the door width is locked, which means you can't easily modify it. In architectural projects, you usually have many different door widths, and it's very important to keep them separated by type so they can be fabricated according to each specific opening. For structural models, on the other hand, we don't really need that level of separation. We can simply use one single door opening type that can adjust to any width we need. To achieve this, I'll go back to the project browser, right-click on the door family, and select Edit. This will open the family editor, where you can modify the family however you want. The first thing I'll do is open the reference level from the project browser. As you can see, the width of the door is controlled by this parameter called rough width. If you want to see that parameter, you can go up here and click on Family Types, and that will display all the parameters that exist in this family. You can see the parameter right here under the Dimensions category. With this parameter selected, I'll click Edit Parameter, and the pop-up window shows that this parameter is actually locked. You can't modify it because this type of parameter is a built-in parameter. What I would normally want to do is switch it from type to instance, but that's not possible with built-in parameters. So instead, I'm going to create a new parameter. I'll click this button here and I'll name it Variable Width. The discipline, type, and group can stay the same. The important part is to make sure we choose instance. Then click OK, And if you want, you can move the parameter up or down in the list using these arrow icons. Let's click OK again. And now we'll assign this new parameter to control the door width. I'll select the dimension and then go up to the top of the screen where you can find the dimension labels. Here you'll see a list of all the parameters that are compatible with this dimension. So I'll simply select variable width. And that's it. But before loading this family back into the project, it's a good idea to save it in a known location so you don't have to repeat this whole process every time. In my case, I already have it saved because I was practicing the tutorial earlier, but you just need to save it wherever you like and give it the name you want. Once that's done, click Load into Project to bring the family back into the model. You could place it directly in the three-dimensional view, but I prefer to go to a plan view and place it close to the other door so we can easily see the difference. Now, as you can see, we can freely modify the width of the door without needing to create a new type every time. Wait a second. Something looks a bit strange here. Let me jump back into the family editor to see what's going on. I'll click Edit Type again and change the variable width to a value larger than the current one. Click OK. And now we can see what's going on. What's happening here is that this is actually another family inside this family. When you have families inside other families, they're called nested families. That's a more advanced topic, but for now we're just going to fix this issue. The problem is that this nested family is still linked to the rough width parameter instead of the new parameter we just created. So I'll cancel this window, select the nested family, and then click Edit Type. Now I'm going to modify its own width by clicking this equal sign button on the right side of the parameter. Take a look here. You can see that the parameter is currently linked to rough width, which appears in blue. So from this list, I'll select our new variable width parameter, forcing this family to follow the new one instead. Finally, I'll click OK on everything and load it back into the project. Whenever you load a family that already exists in the project, Revit will ask how you want to override it. If you're not sure which option to pick, just use the first one. If you want to understand the difference between those options, check out my other video where I explain when it's safe to use the second option. If you use it incorrectly, it can seriously mess up your entire project. All right, now that the family's loaded again, let's check it. And as you can see, the issue is now completely gone. So now I'm going to get rid of the old useless family, which is called door opening, and I'll delete it from the project browser as well, keeping only this new family. At the moment, this family has a rough height of 2032 millimeters, so I'm going to change it. According to the architectural drawings, the wall height should be 2700 millimeters, but the doors are 2400 millimeters high. So I'll enter that value. Finally, I'll rename this type door 2400. Click OK, and let's quickly check how it looks in the three-dimensional view. As you can see, with these doors, we keep this space above the door, which allows us to place a masonry lintel later. All right, now that the family's working perfectly, we can close the family editor. And don't forget to save the changes. Back in the plan view, I can adjust the door widths either by using these blue arrows or by using the Align tool to line them up precisely with the AutoCAD guidelines. From here, I'll simply continue adding doors wherever they appear in the architectural plan. For example, right here. Then I'll keep moving around the model and place the rest of the doors based on the identifiers we saw earlier. Alright, so it looks like those are the only doors in the masonry walls. Now, looking at the internal stud walls, we can see that there are no windows, so all of these openings will be doors. For now, I'm just going to place all doors, not taking care of their widths, and I'll show it in speed motion. Quick heads up here. In this section, we don't actually have a door. If we switch to the 3D view, we can see that this area corresponds to this part right here. The column will be placed here, but we still need a masonry lintel, so we're going to treat this opening as if it were a door. I'll use the Align tool to keep the door width aligned from the wall to the column. Now, if we go back to the 3D view, you can see that we already have the lintel space ready to place the structural column right here. All right, now I'll go ahead and align the rest of the doors using the AutoCAD guide file. Over here, actually joining the walls was not a good idea, so I'm going to unjoin them and then continue aligning everything properly. Another way to position the doors is by checking the identifier tag. For example, this one says 870 millimeters wide. So I can simply select the door and assign that value directly in the properties palette using the width parameter. I'm going to use this method for the remaining doors. Just enter the value and then move them into the correct position. The next step will be placing the windows, but before doing that, I'm going to open visibility and graphics again and add transparency to both doors and windows. All right, now for the windows, I'm going to do exactly the same thing we did earlier for the doors. We just need to load a simple opening window from the Autodesk families. To know exactly where the windows are located in the architectural plan, I'll go back to visibility and graphics, turn door identifiers off and turn window identifiers on. Click OK and go back to the plan view. Now from the architecture tab, I'll select window and try placing one right here in this wall. But as you can see, we immediately get a warning message. This message means that the window we just placed is not visible in this view, and that can happen for several reasons. In this case, the reason is the view range of this view. If you're not completely familiar with how view range works, I'll leave a link to another video where I explain it in detail. For now, I'll just show you how to quickly adjust it so we can see the windows in this plan view. First, I'll go to the 3D view to confirm that the window is actually placed. If I select it, I can see in the properties palette that the sill height is 900 millimeters. If that matches what the architectural design shows, we can leave it as it is and just remember that value. Now I'll go back to the plan view, and in the properties palette, under the extents category, you'll find the view range option. Click on it and this window will appear. Here we can see that the cut plane is currently located 300 millimeters above level 0. So if we want to see our windows in this plan view, this value needs to be higher than the sill height, which in our case was 900 millimeters. So I'll change it to 1000 millimeters. Also, the top extension cannot be lower than the cut plane, so I'll just give it a random value higher than that, something like 1200 millimeters. Click OK, and now we can see the windows in the plan view. But as you can see, this family also doesn't allow us to change the width. So I'm going to repeat the same process we did with the doors. Edit the family, create the variable width parameter, assign it to the dimension, and so on. Also make sure there is no nested family like we had in the door case. If there isn't, simply save the family with a new name and load it back into the project. Once that's done, we can delete the old family since we don't need it anymore. Then we'll edit the new one so it matches the architectural requirements. Since I don't actually have the architectural window schedule for this project, I'll call this one Window 1800, and I'll assign 1800 millimeters to the rough height parameter. Now I'm going to place one window here in this wall just to check how it looks in the three-dimensional view. And as you can see, that's too high. What we need to do is leave space for the masonry lintel above the window, so I'll edit the element and change the height to 1500 millimeters. And don't forget to rename the type as well, so it's easier to find later in the project. All right, with that done, we can now adjust the width of the window using the AutoCAD file as a guide. And if you're lucky, the architect might also indicate the exact window width. In this case, this number 18 represents 1800 millimeters. Now I'll go ahead and place the rest of the windows in fast motion.
Sorry for interrupting, mates. If you're finding this tutorial helpful, you can support the channel with a small donation. That will help and motivate to continue doing these tutorials, as educational content like this usually doesn't get as much support as entertainment channels. Of course, the tutorial will always remain free for everyone. Now let's continue with Senior Revit.
Do you remember we said we would model the stud walls at two different LOD levels? Well, this first version is the simplest one, but I'm actually going to edit it quickly because I forgot to add the plywood layers to the wall structure. So I'll select the wall, go to Edit Type, and then open the Structure Settings. Right now, we only have the space for the stud wall. So I'm going to add 2 additional layers using the Insert button. Not once, but twice. Next, I'll select the first layer and use the Up button to move it outside the core boundary. Then I'll change its function to Finish 1, and now I'll do the same thing on the other side. I'll move this layer below the core boundary and change its function to Finish 2. Finally, we need to change the material as well, since these layers will also be timber. The layer in the middle should be empty, so I'm going to change that material. I'll search for air or something similar. Oh, actually I think I moved the wrong layer, but that's fine. I'll just set the core thickness to 70 millimeters and the plywood layers to 8 millimeters. This message here is simply telling us that some walls are overlapping. Don't worry about that for now. What we can see now is the wall showing a grey space in the middle. This isn't a void, but it helps differentiate it from the plywood material. However, if we go back to the plan view and turn thin lines on, you'll notice that the wall is not actually 70 millimeters thick anymore. You can clearly see the 2 8mm plywood layers, and that doesn't match the architectural plan at all. To fix this, I'll go back to Visibility and Graphics, scroll down until I find Walls, and then expand the subcategories. First, I'm going to turn off Non-Core Layers, which will hide those 8mm plywood layers. But for this to work, you also need to change the detail level of the view to medium. Click OK, and now we only see the core of the wall, which is 70 millimeters thick. Now I'll turn thin lines off again so we can keep working normally in the plan view. If we jump into the 3D view, we can now clearly see the difference between this wall and the 90 millimeter stud wall. So I'll go ahead and do the same adjustment for the rest of the stud walls. Actually, while I was editing this video, I realized there's a much easier way to do this. Instead of modifying the wall structure like you're seeing right now, you can simply duplicate the wall type and then adjust the core thickness accordingly. So if you prefer, you can use that method instead. All right, everything looks good now, so we can wrap up this video here. In the next video, we'll see how to create clean and efficient truss roofs without using those annoying Revit truss families. And in the video after that, I'll show you how to use curtain walls to model real timber stud walls quickly and beautifully.